So, very good noon. We will wait for 1 to 2 minutes and we will start our session. Okay, so let's start our session and some of one will come later on. Okay, so in the previous lecture, we will discuss some important property and some basic theorems. Okay, not the theorems we will discuss, theorem we will discuss today. Okay, so we have discussed the important properties which will be associated with the J transformation, right? So, what are the properties we have discussed? We have discussed the multiplication by a constant term. Okay, we will discuss the linearity of a J transformation, and also we will discuss the multiplication by a polynomial function, suppose a upon k, right? So how we will obtain the j transformation for the different kind of functions using the different properties of a j transformation, so that thing we will discuss in the previous lecture. Okay, so uh, today we will discuss some basic theorems. Okay, so I already told you the theorems, the shifting theorems. Okay, the shifting theorems is one important theorem for obtaining the jet transformation for any such kind of functions. Okay, so what will be the shifting theorem? Okay, so today I will discuss this thing. Okay, shifting theorem, and as well as we will also discuss some examples. Okay, so that thing we will discuss. We will solve some example today. Okay, then we will discuss, if the time permit, then we will discuss the complex translation theorem. Okay, for the j transformation, right? So first you have to start. Okay, so before that we will share my screen so that you will able to see what I will previously taught. Okay, so shifting theorem, right? So I have to share my screen. Yes. Yes, so today we will these things, some important properties, that is the multiplication by a constant. We will also discuss the linearity of a J transform, and we will also discuss about the multiplication with a polynomial functions and how could I derive these things, how could I prove all those things. So today we will discuss about the some theorems. Shifting first we have to consider the shifting theorem, right? So so today's topic says, one second, I have some connection problem. Okay, fine. Yes. Okay, So I think someone is coming. Yes. So today's topics is a shifting theorem, right? So what the shifting theorem is? Okay, shifting theorems is associated with the translation of a jet transformation, right? So the shifting theorem that will presented over here, that will be referred as a real translation in theorem. It should be also called as a translation theorem. Okay, translation theorem, right? It should be also called as a translation theorem. So what this particular theorem is called, if x of t that is equals to 0 for t less than 0, okay, and x of t has the j transform has the j transform of x of z, then so this will be my assumption. Okay, obviously my assumptions. We are considering the time function x of t is equal to 0 for t less than 0. Okay, and we are considering this time function. If I am applying the z transformation, it will come x of z. Okay, so then what happened? So this shifting theorem will be told that these things. So j transformation of x of t minus nt, where it should come I will told you, okay, is equals to z to the power minus n x of z. Okay, one second, I have a call. হ্যাঁ বলুন, কলেজ আছি, একটু ক্লাস নিচ্ছি। হ্যাঁ হ্যাঁ হ্যাঁ, হ্যাঁ হ্যাঁ ঠিক। Okay, so if this equation will be satisfying the shifting theorem. Shifting means we have to shift the signals. Okay, suppose if we have a signals like this, okay, so there must have shifting either right shift or either left shift. Okay, so shifting will be divided into the two part. Okay, this shifting means shifting of a signals. Okay, shifting will be divided into the two part. One is called the right shift. Okay, another one is called the left shift. Okay, right shift and the left shift. Right. So this particular function is actually under the time delay. Okay. So z to the power minus n is actually delay operator. It actually called as a delay operator, and this particular function is actually called the right shifting functions. How would I justify this right shifting function? I give you one diagram so that you will able to see, able to check. So if I will draw one graphical representation like this, okay, so if in this axis we are putting the time function x of t, right? And in this axis we are putting the time period t. Okay, so I am considering over here 1 and this should be considered as 0, and here we are considering like 2, like 3, like all those things. Okay, so and here we are putting, so that means we are considering x of t is equal to 0 when t less than 0. This will be my condition. Okay, so the x of t will be 0, and when x of t is equal to 1, okay, so that value we are considering. So over here we are considering the time period t, 2t, 3t, 4t, 5t, 60, 70, and supposed to be 80, a number of time interval. Okay, and now I have draw the graph like this. Okay, I have draw the graph like this. Okay, so this will be the signal, right? So this is actually nothing but a the values of x of t in this particular case is equals to 1. See, the values of x of t is actually 1. Okay, so this will be called as a shifting graph. Okay, shifting graph having a value of 1 into t minus of t. That means this particular unit step function, suppose if it is a unit step function, okay, so this particular unit step function is delayed by one sampling period, right? So this particular graph is signified that the unit step function is delayed by one sampling period. Okay, so this will be my delay. Okay, if this particular unit step function will be start from here, then it should be considered as a no delay. That means then delay will be 0, as it should be starting from the values of t time period. So the delay should be this particular part. This will be my delay. Okay, and the delay should be one one sampling period. Okay, if I will draw the unit step function like this, okay, so this will be my actually called the shifting. Okay, the shifting of a particular function. Okay, either it should be the left shift or it should be the right shift. Okay, so if I will consider, if your function will be like this, if my function should be like this, it should be xt and it should be my t, and this value will be supposed to be over here 1, and this will be 0, this t, 2t, 3t, 4t, 5t, 60, 70, and 80. Okay, if the unit step function will be starting from there, so then it should be considered value of a function of t minus 40. Okay, as it should be starting from this particular time interval, so delay should be this part. That means over here in this particular, supposed to be, this is my figure 1 and this is my figure 2. Okay, so in the figure 1, the unit step function, this is my unit step function supposed to be, this will be the value of my unit step function, will be will be delayed by one sampling time in time one sampling period, but if I will see in this figure 2, the unit step function is delayed by 4 sampling period, is delayed by 4 sampling periods, like this, from there to there will be delay by 40. So that is why my unit step function will be the function of xt. Function of xt will be, the value of xt will be 1. See over here, the value of xt will be my 1 into t minus, actually the t value, this will be t minus of 40, right? But over here it should be considered as t minus capital T, right? So that will be the shifting of a unit step function. Okay, it may happen if I will considering the unit ramp function, delay must be increased. Either delay will be in a right shift or the delay will be in a left shift. If it is considering as a left shift, okay, so this should be considered as a right shift. Okay, as the delay will be in this particular direction, so it should be considered as a, I will consider this will be the right side, right shift. Right. Here also we will considering the right shift also. Okay. Right shift. Okay. But in case of a left shift, if I will again redraw these things, again I will redraw these things. Suppose this is xt. Okay. And this will be t. So in this particular part, this is t, this is 2t, this is 3t, this is 4t, this is 5t, like this. But if we will considering the left shift, we are doing the minus of t, minus of 2t, minus of 3t, like this, right? So for that case, if we will considering the left shift, if I will considering the left shift, the value of x of t is equal to 1, the values of x of t is equal to 1. So for that case, if it will be starting from there, then value of the unit step function, the value of unit step function will be considered as a, the value is 1 t plus t. Okay, so that means it will come like this. That means if I will consider these things, how could I this come? T minus of minus t, right? So it should come 1 1 t plus t in case of a left shift, right? Again, but if it is come from 3t, suppose if it is come from 3t, so this will be 0, this will be my 1. We are considering over here xt. This will be your minus t. This will be your minus 2t. This side we will considering minus of 3t. This side we are considering 4t. But if it is, if we are shifting the unit step function from there, then the unit step function, this particular function, it will be treated as treated as 1 t minus 3t. That means the delay should be this period, but delay in a left shift. Right. So for that cases, the unit step function, for that case, the unit step function will be considered as 1 t plus, sorry, t plus 3t. Yeah, t plus 3t, right? So how could I these things? That means t minus of minus 3t. Okay. So then it will come t plus 3t. Okay. So this will be my, the values of my unit step function for the left shift. Okay, this is actually called the shifting theorem of any particular function. We are considering over here, I give you one example of a unit step function. Okay, the shifting theorem will be valid for all the functions. That means all the function which I already discussed. That means unit step function, unit ramp function, polynomial functions, and as well as the exponential function and the sinusoidal function. So all this function that will considered as a shifting theorem. Okay, so using the unit step function, I am showing how this particular unit step function we are considering the shifting theorem, right? So if I will go from the very beginning, then it will come this like this. So here it should be considered as a, which type of shifting? Tell me, tell me. This is my right shifting or left shifting? So this is my right shifting. So Z transformation of x of t minus nt. Nt, okay, where where n will be vary from 0, 1, 2 like this. N will be nothing but the values of n is equal to 1, is equal to 2. So if it is t, that means 2t. So for that cases, if I will get transforming of x of t minus 2t, okay, z transformation of x of t minus 3t, like this. So we are considering the values of n should be 0, 1, 2 up to infinity, right? So this will be considered as my right shifting. Okay, this will be considered as my right shifting. Okay, so the shifting theorem is told that if x of t is equal to 0 for t less than 0, and if this particular time period, this particular time function has the z transformation of x of z, then the equation will becomes z of z transformation of x of t minus nt, that is equals to the z minus of n into z. Okay, sorry, x of z, okay, into x of n, where z of minus n is actually called the delay operator. How much delay we will considering? So z to the power minus n, where n will be vary from again 0, 1, 2 up to infinity, but it is for the right shift. Okay, but in case of a left shift, in case of a left shift, what we will do? But it is a time advance. That means time over here, if I will considering the right shifting, there must have a time delay. Okay, but if I will considering the left shifting, it should be considered as a time advance. Okay, that means we are considering the positive functions, so it should be considered as a time advance in case of a left shifting. So for that cases, if I will considering for the left shifting, z to the power minus n will be considered as a advance operator. Okay, it should be considered as a advance operator. Okay, advance operator for left shifting, and z to the power minus n will be considered as a delay operator in case of a right shifting. Okay, but now we are considering for the right shifting. So this will be my very important equation. Okay, keep remind these things, because whenever we did the application part, we have to we have to know this particular equation. Otherwise, we cannot solve this. Okay. So, but in case of a right shifting, sorry, in case of a left shifting, in case of a left shifting, what will be my equation? Transform of x of t plus nt. Is it? Am I right? Am I wrong or am I right? Hello.
Right, sir.
Okay. So for the left shifting, I told you, for the left shifting, it should be considered as a this one. It should be considered as this t plus multi. So for that cases, in case of a left shifting, it should be considered as a z transformation of x of t plus nt. So if I will transforming the z transformation, it will considered. Okay, okay. One correction is there. If it will be considered for the left shifting, so z to the power minus n, it should be considered as a delay operator. But in case of a left shifting, z to the power plus n, it should be considered as a advance operator. Okay, some small mistake. Okay, z to the power. I will told you, in case of a left shifting, in case of a left shifting, z to the power n, it should be considered as a advance advance operator. Okay, but in case of a right shifting, z to the power minus a, it should be considered as a delay operator. Okay, keep remind these things. Okay, keep remind this thing. Okay, so in case of a left shifting, it should be considered as z of x of t plus nt. Now you have z transforming of this particular function, unit step function. So if I will z transform of this, so it will come z to the power n, sorry, z to the power n, that means advance operator into x of z minus of x of z minus of summation of k is equal to 0 to n minus 1, as we will considering this part, that means negative slope. So this is the n0, n minus 1, n minus 2, n minus 3, n minus 4, like this. So the values of k, if the x of t we will be considered as x of kt. Okay, so in case of a left shifting, the values of k will be vary from 0, n minus 1, n minus 2, n minus 3, like n minus infinity, like this. Okay, so like over here, if I will transforming the z transformation, so x of t we will considering x of kt. So now we have to simplify these things. Okay, so summation over k is equal to k is equal to 0 to n minus 1 into x of kt into the inverse from z to the power minus k, right? So this will be my equation for the left shifting. This is also important term for the application part. Okay, so this particular equation will be for the time delay. Okay, this particular equation will be for my time delay, and this particular equation this particular equation will be considered as a time advance. Okay, where we can say this particular n value, n is 0, either n should be 0 or a positive integer. Okay, because for that case, in the previous case when we have dealt the right shifting, we are considering x of t is equal to 0 when t less than 0. Okay, so for that cases, if I will considering x of kt, okay, that is equals to 0 when the values of k will be varies from 0, 1, 2 up to infinity. So for that case is the values of n, that will also varies from 0, 1 to infinity. So that is why we will considering the values of n, either it should be 0 or it should be the positive integers. Okay, not the negative integers. Okay, so how could I solve these things? How could this particular function will become? So there will have some proof. Okay, so there will have some proof. So how could I prove this particular equation? Okay, now we have to write the proof. Okay, so how could I prove these things? Okay, so now we have to come the proof part. Okay, so my equation is the z transformation of x of t plus nt, right? That is equals to z to the power n x of z minus summation of k is equal to 0 to n minus 1 x of kt into z to the power minus k, right? So now we have to prove these equations. So how could I prove this? How would I prove this? Suppose this is my equation 1, considering this is my equation 1, okay, and supposed to be we are considering this one is my equation 2. Okay, so how could I prove this? To prove the equation, so first we have to prove the equation of first one. Okay, first we have to prove the previous one. Okay, First, we have to prove these things. Z transformation of x of t minus nt, that is equals to z to the power minus n x of z, right? So suppose this is my equation 1 and this is my equation 2. So first we have to prove these two equations, okay, this one and this one. So first we have to prove this equation. Okay, so how could I prove these things? Okay, so to prove the equation 2, so to prove the equation 2, sorry, prove the equation 1, first you have to prove this equation. Okay, so you have to note that what will be your notation. The notation will be the z transformation of x of t minus nt, that is equals to इसको अगर we have to did the z transformation. One second, yes, I have a call. Hello, 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 hello. Okay, so if we will prove the j this one, so if I will uh, obtain the z transformation of this particular unit step function, then it will come like this: the summation of k is equal to 0 to infinity, okay, x of, we are considering x of t as a x of kt, x of kt minus nt. This x of t we are considering x of kt, where the values of k will be vary from 0, 1 to up to infinity. So that is 0 to infinity x of kt minus of nt into z to the power minus k. Okay, after doing the z transformation, right? So if now we have to did the delay operator, we have to implement the delay operator for the right shifting, right? So we have to implement the delay operator, z to the power minus n summation of k is equal to 0 to infinity x of kt minus of nt into as we are considering, we are implementing the delay, we are implementing the delay operator. So here also we have to consider minus of k minus n. Okay, keep remind these things. Okay, when we have to implement the delay operator, okay, so that part would be minus of n minus k minus n. Okay, as we are considering the values of k will be varies from 0, n minus 1, n minus 2, like this na. Okay, so we have considering after doing the z transformation of this of a unit shape function, it will come like this. Okay, so again the next step by defining we are considering this k minus n, we are defining something. Okay, keep remind these things, we are defining this k minus n, we are defining the k minus n, that is equals to m. Anything you can choose. I am choosing m, you can choose p, you can choose q, anything. Okay, so from the equation, so supposed to be this is my, this equation will be considered as my equation 3. So equation 1 will be my this, equation 2 will be my this, and equation 3 will be my this. So if we will defining the k minus n as a m, so from the equation 3, okay, so from the equation 3, that can be written as, that can be written as How could I write these things? It should be written as the z transformation of x of t minus nt. That means this side part will be same. Okay, that is equals to z of minus n. Okay, summation of tell me what? Tell me summation of क्या होगा? As we will considering, we are defining the k minus n is equals to m, right? So k minus m equal to defining. So m is actually nothing but a minus of n. Okay. So already I will defining the values of k. So m, now we have to considering the values of m actually. So m value that will varies from minus n to infinity. Okay, so it will be considered as minus n to infinity. That means whatever the values we are writing, respective of the values of m. Okay, as we are defining k minus n as a m, right? So the limitation for the values of m that will starting from minus n to infinity. So it should be considered as x of mt. Okay, we are not considering over here k, so we are not considering kt. Okay, we are considering mt. So this m is will be defining the k minus n, right? So for that case, we are writing x of mt into z to the power minus m, because m we are considering k minus m, and if I will see the previous equation, it should be considered as k minus n. So we are considering z to the power minus m, right? So we can again write since now we have to solve these things. Okay, so since x of mt that is equals to 0, okay, for m less than 0, okay, so we can change the lower limit of the summation from the m is equal to minus m to m is equal to 0. Okay, when we have did the x of kt that is equals to 0 for k less than 0, so for that case my summation will be like this: k is equal to 0 to infinity. But for this case, if I am choosing x of mt, so my summation will be changes. My summation will be m is equal to minus n to up to infinity. Okay, so now we have to change these things. Okay, as we are considering the x of mt is equal to 0 for m less than 0. So for that case, we can write. So if I will did this thing, see x of mt is equal to 0 for m less than 0. So we can change. So we can write. We can change. Sorry. We can change the lower limit. We can change the lower limit of the summation from m is equal to minus n to m is equal to minus n. We are changing m less than 0. So for that cases, we are changing the values m is equal to 0, right? So hence we can write the equation. We can write the equation like this: z z transformation of x of t minus nt that is equals to z to the power minus n summation of m is equal to 0 to infinity. That means we are only changing the lower limit. Okay, in the previous equation the m value will be minus n, as we are defining k minus n is equal to m. Okay, now if I will considering the x of mt, this particular value x of mt is equal to 0 for the m less than 0, for that case we are changing the only the lower limit of the summation from m is equal to minus n to m is equal to 0. Now over here it should be considered as m is equal to minus n, right? But if I will rewrite the equation after changing the lower limit, it should be considered as m is equal to 0 to infinity, right? So x of mt, x of mt, z to the power minus m, right? So from there it will come z to the power minus n. So this particular term, we can consider this particular term, okay, this particular term we will consider x of z. So suppose this equation will be my, so this is number 3 equation, okay, and now we will considering this equation as a number 4, okay. So z transformation of x of t minus nt, that would come z minus of x of z, okay. So where, however, so if check this one, in the previous case we are doing what thing, k is equal to 0 to infinity x of kt into z to the power minus k. So if this such kind of equation will be there, we have write what, x of z, okay. So this will be my same equation, but we are considering the k minus n, we are considering the values of m, right? So if I will write this equation, so this will be my z transformation of this particular function, okay. So the z transformation of x of t minus nt, that will become z to the power minus n into x of z, okay. This is for my right shifting or left shifting. This is for my right shifting or left shifting, tell me. This is for my right shifting. This is for my right shifting. Okay. Where this z of n minus n, z of minus n will be considered as a delay operator. Okay. This will be considered as my delay operator. Okay. So I need to check how much time. I have to stop the session for today, okay, because I have a class, another class, okay. So up to this, it is understandable. Next day, that means in the Tuesday, in the next week, I will again discuss the latter part, okay. That means from the right shifting, how could I prove this equation? How could I prove this equation? Okay, so that thing we will discuss in the next part, okay. So thank you, I will stop the session for today. Thank you very much, all are requested to leave the session.